Assalamualaikum warahmatullahi wabarakatuh, and hi everybody. So now I'm going to explain on analysis of covariance, or the short name for analysis of covariance is ANCOVA. Okay, when we use ANCOVA, when we involve two groups, pre-test, post-test design, or also known as quasi-experimental research design, where you use a pre-test and post-test. So different between ANCOVA with repeated measure is that repeated measure does not involve a control group and experimental group, only involve one group, but there are three types of tests. But in ANCOVA, there are two groups, which are control group and experimental group, and you will have pre-test and post-test. You will give the group pre-test and post-test. So the scores on the pre-test are treated as covariate. Yeah, so pre-test is also known as the covariate. That's why it's known as analysis of covariance, where the pre-test is covariate to control for pre-existing differences between the group. So the purpose of we do ANCOVA is for us to control the pre-existing differences, perbezaan awal yang ada between the two group, which are the experimental group and the control group. Okay, so this makes ANCOVA very useful in situation when you have quite small sample sizes and only small or medium effect size. So ANCOVA is very helpful also when your sample, when doing the experimental research design, your sample is so small. So ANCOVA will cover it for you. So how do we choose appropriate covariates? ANCOVA can be used to control for one or more covariate at the same time. Yeah. So, but usually in education, we only have one covariate. But ANCOVA actually can control more than one covariate at the same time. So the variable that you choose as your covariate should be continuous variables, measured reliability, correlate significantly with dependent variables. So ini syarat untuk choosing covariate. Continuous variables such as test scores, and it measured reliability, and it must have significant correlation or relationship with the dependent variables. So the covariate must be measured before the treatment or experimental manipulation is performed. So covariate here is the pre-test. So what will be the assumptions that you have to fulfill for doing ANCOVA? There are 6. Depends on your research. Can be 5 or 6 actually. So the first one, each group sample is drawn from normally distributed population. This is very common for all of you. And second one, each samples within each sample, the observation are sampled randomly. So randomly selected, normally distributed, very common. And the third assumption, also very common for all of you, you have to run Levin test in order to see if there is any equal variance assumed among the two population. So for Levin test, P must be more than 0.05. This is depends on your types of research. If you're having more than one covariate, meaning here you have to make sure that there are correlation between one covariate with another covariate, and that correlation must be a strong correlation. And if you only have one covariate, you don't have to do this. The fifth assumption is linearity. You have to run a scatter plot to see the relationship between the dependent variable and your covariate is linear. So you can run scatter plot in descriptive analysis. Scatter plot can be found in descriptive analysis as well. And then you have to run homogeneity of regression slope. This is to see the relationship between the covariates and the dependent variable, or the pre-test and the post-test for each group is the same. You want to know if there is any strong relationship between the covariates and the DV. So similar slope on the regression line for each group, P must be more than 0.05. So in one way ANCOVA, it involves one independent variables, which two or more levels, condition or group. Only one independent variables, one dependent variables and one or more continuous covariate. So ini adalah syarat untuk jalankan ANCOVA. You must have these three types of data, ya. Independent variables, dependent variables, and covariate, continuous covariate. So covariate usually is the pre-test, independent variable is the post-test. Sorry, independent variable is the group, control group and experimental group, and dependent variables is the post-test. So then you have to write your null hypothesis. This is the way of writing null hypothesis for ANCOVA. There is no significant difference in dependent variable for independent variable, which in this case you have two groups, level 1 and level 2, or experimental group and control group, while controlling for their pretest. So pretest is the covariate, and this would be the alternative hypothesis. There is a significant difference in dependent variable for independent variables, level 1 and level 2, while controlling for their pretest score. So make sure if you want to do ANCOVA, you write the hypothesis like this. Yeah. This is another way of writing the hypothesis, but I would suggest you to use the one in words or sentence. So let's look at case 1, example 1. A one-way between group analysis of covariance was conducted to compare the effectiveness of two different interventions designed to reduce participant fear of statistics. So remember, in ANCOVA, you need two data. First is the covariate. So covariate is the pretest, and then you need the independent independent variable, which at least have two levels. So in this case, two different intervention is the independent variables. Yeah, maybe you have experimental group and control group here, and then you need a dependent variable. So dependent variable is score for or achievement for fear of statistics. That would be the dependent variable or your post-test 2. So here the independent variable was the type of intervention, which is math skills and confidence building, two groups. Dependent variable, score of the fear statistic, and the covariate is the pre-test or the pre-intervention administration for fear of statistics. So procedure for one-way ANOVA, click analyze, choose general linear model and choose univariate, just like the one that you use for ANOVA. Put DV, in the DV box, put your DV, and in the fixed factor, put your IV. And in the covariate, you put your pre-test score. Yeah. Click on the model button, click on full factorial in the specific model section, click on continue and click on the options button. And then in the top section label for the option buttons, you choose estimated marginal mean, click on your IV, and then click on the arrow to move it into the box label display mean for. This will provide you with the mean score on your dependent variable for each group, adjusted for the influence of the covariate. So in the bottom section of the option dialog box, choose descriptive statistic, estimate of effect size, and homogeneity test. Okay, and then click on continue and then OK. So important for you to choose estimate of effect size and homogeneity test for you to fulfill the assumption. So this is the report of a scatter plot from the linearity. So the relationship is clearly linear. This assumption is fulfilled. So linearity can be done using scatter plot in descriptive statistic. And then for the homogeneity of regression slope, you will look at homogeneity of regression slope so that you can look at relationship between the covariate and DV for each group is the same. So similar slope on the regression line for each group. P must be 0.05. So you look at here. Yeah, you look at fear of statistic 1, you can see that the result is 0.816. So when it's 0.816, it is more than 0.05. So this assumption for homogeneity of regression slope is fulfilled. Yeah. And then this is the output for descriptive statistic. Okay. So from the result of descriptive statistic, there's only slightly different of mean between group 1 and group 2, between math skill and confidence building. So this is the result of Levin test of equality of error variance. So there's one assumption that you have to fulfill is equal variance assumed. So from here, the result is significant value is 0.7110, which is more than 0.05. So the variance are equal. And this is the main ANCOVA result, test of between subject effect. You may look at group, yeah. You may look at group, look at the DF, look at the F test, the result of F test, significant value, and partial eta squared. So this is the way of you read or reading the SPSS output. F, DF for group, DF for error, 127 is, and this is the result for F test, 0.763, P value 0.39, and partial eta squared is 0.027. So the result is not significant because P is more than 0.05. There is no significant difference in the field of statistic test score for participant in the math skill group and the confidence building group after controlling for score on the field of statistics test administered prior to the intervention. Tak ada perbezaan pun. Yang dari mean different pun, you can see that there is not much mean difference. Yeah. So what's the function of partial eta squared value? So the value in this case is only 0.27, which means there is a small effect size. Yeah. So this value also indicate how much of the variance in the dependent variable is explained by the independent variable. So in this example, we are able to explain only 2.7% of the variance. How about field of statistic 1? What does this mean? So this indicate whether there is a significant relationship between the covariate and the dependent variable. Remember, one of the assumption is that there is a relationship between covariate and the dependent variable, or the pre-test with the post-test. So when you look at this line, you look at significant value. Significant value here is 0.000, which is less, which actually means less than 0.0005. Yeah. So this is less than 0.05. So our covariate is significant. Partial eta squared 0.75 is explained that 75% of the variance in the dependent variables. And this is the output for estimated marginal means. We can see that there is a mean difference between math skills and confidence building, but a very small difference. Yeah. So adjusted refers to the fact that effect of covariate has been statistically removed. So after adjusting for, here we can see that the mean difference between math skill and confidence building in the pre-test sangat kecil. So maksudnya they are almost the same level, because the difference has been removed by ANCOVA. Yeah? ANCOVA. So after adjusting for pre-intervention score, there was no significant difference between the two intervention group on post-intervention score of the field of statistics. This is the way of you report it. There was a strong relationship between the pre-intervention and post-intervention scores on the field of statistics, as indicated by a partial eta squared value of 0.75. Yeah. So this table, this row, for you to find out the partial eta squared, for you to report this part. There was a strong relationship between the pre-intervention and post-intervention. Terdapat hubungan yang sangat kuat antara pre-intervention and post-intervention. Macam mana kita nak tahu? Sebab the value of partial eta squared is 0.75. This is another example. A teacher want to investigate whether 3 different teaching methods. Now there are 3 different teaching methods: cooperative learning, problem-based learning, and inquiry-based learning. So you may test it to different groups, yeah. And you want to look at student achievement in science. So this is the step: state the null and alternative hypothesis, set the significant level, check assumption, analyze the data using SPSS, make a decision, and draw a conclusion. So this is the null hypothesis. Yeah, you may read this. There is no significant difference between the 3 groups, yeah, while controlling the pretest, whereas alternative hypothesis, there is a significant difference. And then set the alpha value, state the assumption, run the SPSS, check the assumption, and what is the result. So from this result, we can see that from group, yeah, this one, it is 0.005, less than 0.01. My mistake here. So we reject the null hypothesis. So you draw the conclusion from this row, yeah, from the level. Okay. And this will be another example. You may read it. Thank you very much.